Hi, this is Mr. Manley. In this video, we're going to look at matrices in context. And this will give you a better sense for why multiplication works the way it does and how it yields a meaningful result with matrices. In order to have an idea of what's going on here, I suggest that you pause the video now, read the problem, and then come back and listen to what I'm going to say about it. Welcome back. Here, what we've got is these towns that are selling these products for various prices. And what I'm going to do is I'm going to set up a matrix multiplication here that makes sense, has a result that makes sense, and see what the result means. Part of this is predicated upon understanding that when we multiply matrices, remember when you learned how to multiply matrices, that there was this idea that in order to multiply them, these two numbers need to match. Now in this case, we're going to say not only do those two numbers need to match, but the sense of them, what those two numbers mean, needs to match as well. So I'm going to show you what I mean by that, and you'll see if you can follow. And yes, it's going to be a little bit challenging. The first thing that we would want to do is label this matrix as a 3 by 3, and then label the rows and columns according to what they are. And we actually have that up here already. So I'm just going to say that I've got C, H, and I'm going to go B for a bag of chips. Those are the really important numbers, or those are the really important labels here that will really make sense of what I'm going to do. I'm going to move this over actually like this, C, H, B. And I don't want to rewrite all the numbers. I just want to set that matrix there. Now watch, when I put this matrix here, and it's a 3 by 3 matrix, and then I'm going to put a 1 by 3 matrix over here because I want to multiply these. And I know that to multiply them, these numbers need to match. So I need this to be 3 columns. And in order to get 3 columns, I'm going to go like this. And that's going to be, again, C, H, B for candy bars, hot dogs, and bag of chips. And then the row is going to be money. Okay, now remember, we moved this matrix over. This matrix here, we moved it over there. So we're not paying attention to this anymore. We can cross that out and say we're not looking at that. That matrix moves over here, and I'm not going to take the time to write all the numbers in here, but those numbers are all in there, 3 by 3. Now I'm going to fill in this matrix here, right there. I'm going to fill that in with the numbers that go with them. And what is it? It's the price of each product. So the candy bars are 80 cents. The hot dogs are $1.30. I'll just put 1.3. And the bag of chips is 40 cents. I'm just going to put a 0.4 for that. All right, now I can multiply these two matrices. And I can see that these two numbers match, which means that I can multiply them. And then I can also see that not only do these two numbers match, but what they mean matches as well. Because this 3 is the 3 columns of this matrix, C, H, and B. And this 3 is the 3 rows of this matrix, 1, 2, 3 rows. And do you see how those match? You see CHB matches CHB. So in context with these problems, you're looking for two things. One is you're setting up the multiplication of two matrices where these numbers have to match if you're going to multiply them. And then in addition to that, you want the labels to match as well. So I want the column labels on this matrix to match the row labels on this matrix. I'm not going to do the multiplication now because we have another lesson for that to teach you multiplication, but I will just point out that what's the result of multiplying them? The result is a 1 by 3. So these outside numbers give me the result. So I'm going to have a 1 by 3 matrix here. And what are the rows and columns of this matrix going to be? It's going to be money, and then it's going to be the towns, Tomsville, Newton, and Glen City. And when I multiply this one matrix by this other matrix and get this result, what it's going to show me is what's the total money made in Tomsville? What's the total money made in Newton? What's the total money made in Glen City? Now that's a pretty neat result, really, because we're talking about Tomsville, Newton, and Glen City. But imagine if I had 100 cities. What if I had 1,000 cities to check on, or I wanted data on those? That's a lot of calculations for 1,000 different cities. But if I can get it into a matrix, that really cuts down my evaluative effort. My calculation is really automated and can happen with the snap of a finger. And this is actually what Excel is for. So you know about Excel, and a lot of people, their experience with Excel is kind of like a data sheet. People will do a lot of text entry in Excel as well. But what Excel is really for is to automate matrix calculations. That's one thing that it's for, that it's not used for as much, that is really powerful, a really powerful sort of calculation that can be automated when we use matrices to represent, or matrices to capture and put our numbers into a form that can be operated upon at the snap of a finger.